Doing this problem called spiral matrix. Given a m cross n matrix, return all elements of the matrix in spiral order. Okay, so I have to go to 1 to 2 to 3 and 6 9. So you got the idea. How to do it is something we have to think about. Okay, maybe let's use a whiteboard. So let's start with a, is it a square matrix? No, it says m cross n matrix. So um, for a 1 cross 1 matrix, it's easy. You just return same guy. For a 1 cross 2, okay, so let's check the, let's take this 3 cross 4 matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the idea is you have to, there are different directions, right? So either you can go right. Essentially, there are 4 different directions that you can go, and you are going in all different directions. So for example, at this point, you're going in this right direction, and then all of a sudden you start going in the down direction. Then you start going in the left direction, and then you start going in the up direction. Now, oh, not here. And so, and then you start going. What was that? You can have a scalar, and then you start going in this and this. This is where you stop. So you change direction. So one thing is you have to figure out when to change direction, right? And which is when you reach a boundary, when you reach boundary. But also your boundary is coming reducing, right? So for example, when you go till here, you knew your boundary was where, and once you hit that wall, first thing you notice that you are done with this row, so your upper boundary is already reduced and comes here, and then from here you go till here. So once you do this, you shift your boundary here, and then from here you see you go down, and once you reach down, you also remove your this boundary here, and then you shift to this direction, and once you reached here, you remove your this boundary, and then you move up. And once you go here, you should, so you keep, so there are two things you have to do: change direction and shift boundary, right? So uh, walk in mentioned direction, till boundary, and then there are two things to do. One is shift boundary, and second is change direction. And do this, and you do it till how long will you do that? Maybe keep count of the number of nodes till all nodes traveled. Okay, so let's try this in code. How does it look? So first we have to have, there are 4 different directions. So let's call direction. You have left, right, then you move up or you move down. So that's one bit, and you initialize with the, you have to go left to begin with, right? And now you're also looking at the different, there are four boundaries. So let's define that as well. Into, let's call it left boundary. Sorry about that. So left boundary is at 0. Let's call it left column, right? So yeah, the left column is 0, and the right column is matrix of 0 dot length minus 1, and then left, right, up, down, up row, top row, bottom row. Okay, so top row is obviously 0, and bottom row is matrix length minus 1. So we have our all the four different thing, and let's also maintain a count how many nodes you have traversed, right? And so this can be our outer loop. So while count is not equals to matrix dot length times matrix of 0 dot length, then we will keep traversing. And how are we traversing? So we know the direction, whichever direction it is. So it all depends on the direction. So if b equals to direction dot left, then what are we doing? Then we are moving in the right direction. So we have to also initialize the current, right? So current x and y. Let's call it x and y. So x equals to 0, y equals to 0. This is the current position. Okay, so now when you're going towards to the right direction, you will go till the when you go in the right, you will whatever row you are on, you will go till the right column, right? So for int column equals to 0, not 0, so column equals to whatever y is, or rather I would say for okay, so column equals to left column, column is less than equals to right column, column plus plus. What do you do? Do you have to print or what? What is the output? Return all elements of a matrix in a spiral order, a list of integers. Okay, so let's define list of integer, list equals to new array list. So we go from left column to right column, and what do we do exactly? We do list dot add matrix of I feel like I can just call up row up. So um, top row and column, right? Okay, this is fair enough. So you have traversed the. I'm feeling like I might not need this, but let's see. So I traverse. I go from Whatever is the current top row, I traverse that top row. Once I have done that, there are two things like I mentioned, shift direction and so direction equals to, now next direction will be down, and your top row is done. So top row plus plus. Okay. Now go to else. If your direction is down, okay, then again, so now row equals to top row is less than equals to bottom row, and row plus plus. You add matrix. You are adding what? So column is fixed. Row, you're moving the rightmost column. So right column. You do that, and after that you change your direction to left, and also your rightmost column is done, so right column minus minus. Okay, and if your direction is left, then you are going in the column starts from right column. Column is greater than equals to left column, and column minus minus. So currently start add matrix of bottom row column, and then direction is equals to direction dot up on, and the bottom row is incremented. Or you can do, so there is no count, just do list dot size. Yeah, and the final bit, which is moving up. So for row equals to bottom row is greater than equals to whatever is now the top row minus minus, start add matrix row left column. Left column is done, and direction changes to left. Alright, run code. And finally we return the list. And we got a wrong answer. 1, 2, 3 was correct. Output 1, 2, 3, 6, 9 was also fine. Then all of a sudden you went to 4. Why was that? So 1, 2, 3, 6, 9, and then you have to, after down, you must change it to left, right? Yes, so after now you change it to left, and in the left you are making your column change. So your column is changing, correct? But why is it 4, 5? Let's basic idea, let's look at it. So after left, you have to go down. And after you have gone left, essentially your top row increases. So these two is correct. After you go down, you have to go left. And after you have gone down, your right column shifts, which is also fine. After you go left, you have to go up. And after you have gone up, your bottom row shifts up. Plus plus minus minus. Minus minus, right? And here left column plus plus is correct. Yeah, okay, run code. Okay, 1, 2, 3 is correct. 6, 9 is correct. Again, then 4, 5, and 8, 7. So 1, 2, 3, 6, 9, and then 4, 5, 8, 7. After 1, 6, 9, how am I going to 4? Okay, because when I go this, I don't understand. What did I not change? So when I'm going in left direction, because 1, 2, 3, 6, 9 is correct. From 9, I'm going to 4 somehow. Clearly, the direction is left. Oh, why is direction left? Yeah, direction is left only. So here, that's the problem. So you have to initialize. Okay, basic mistake. Your initial direction is right, and you start going with the right. I don't even know how it. Okay. Fine. Submit. It's still wrong also. Okay. 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, and 7, 6, and 6, 7. Okay. Let's see if our approach will work for this input or not. Go to whiteboard. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our based on our first approach, we'll go from right to this. So I'll do 1, 2, 3, 4, and then top row will in this is our top row. So then 8, 12, and now this is our right column. So then 11, 9, 10, 11, 10, 9, 11, 10, 9 works, and then you move up. But when you move up, there is nothing but 5. So you go to 5, which is also fine. Then you go to 6. But somehow it goes to 7, 6. So after up, you have to go right. Again, I think that's a bit I might have missed. Yeah, so after up again, that's the same thing. Okay, so I'm back on the. So here again, after up, I made it left instead of right. So that was the problem. Okay. Basically, I confused left and right like a stupid guy, but okay.